Let's think about the inside of the eyeball for a moment.
This is a 2D representation of what actually is a curved surface inside your eyeball, lined with cells, the receptor cells that pick up the light. There are two sorts of receptor cells. The rods, shaped kind of blunt at the top, and the cones, shaped more pointedly. And they're distributed around your retina in a certain pattern. The rods are distributed more around the outside and the cones more in the middle. And in the very middle is the highest concentration of cones at the point called the fovea. Really too small to represent, so I'll draw a circle around it. And that is the place where you get the sharpest vision. The rods have a slightly different function. They can pick up lower levels of light, and they can actually band together and pull resources to help you to see in very low light levels. But to see something at its very clearest, you need to get it right in the centre of your visual field. It's a bit like a target that you have to aim for, like the telescopic sight on a gun. Here, I'm looking through a plastic bottle to roughly simulate the difference between central vision and peripheral vision. You catch something out of the corner of your eye, and your attention shifts onto it. And your attention carries your eyeball along with it. Once you've got the thing in the centre, you can get a better image of it. The term central fixation might lead you to think that you have to fix your gaze on this central clear point. But the mechanism of vision is a dynamic one. It only works in the presence of movement. Your brain builds up its images at lightning speed from a sequence of ever-changing impulses which come from the rapid scanning motion of the eye. If your central fixation is good, you can tell where you're looking, whether you're looking at one letter or another, for example. You can shift your attention between 2 points and be able to feel the difference between when you're looking at one point and when you're looking at the other. You should also be able to tell when you're looking directly at a point, say this bottom of the T, and when you're looking away from it. Now, I'm going to ask you to shift your attention between the middle of one letter O and the middle of the other letter O. Whichever one you're looking at should feel more immediate and distinct in your awareness. Whichever one you're looking away from should feel less distinct, as though it becomes more part of the background as soon as you look away from it. Once you can demonstrate this effect to yourself with points that are some distance apart from each other, try it with points that are closer together. When you look at the inside of a single O, can you shift between the two inner edges? You can practice central fixation by looking for certain things in your environment. For example, by counting the spots on the wallpaper, or by seeing how many corners you can find in the room. The idea is to train yourself to pay attention. You don't have to count every spot or every corner. You just keep shifting your attention from one point to the next, and let your eyes feel easy and soft. Try telling yourself that today you're going to notice the colour red, and then see how many times you notice it, even after you've forgotten that that's what you were going to do. When you're in a crowd, try looking easily and rapidly from one head to the next, pausing just long enough on each head to register each time what colour hair that person has.